Okay, let's move on to solving some more modulus equations. And we've used graphs for these before, and I'm going to start off that way. But where we can see some shortcuts, maybe we'll start looking for some of those as well. So the first one, I'm going to draw two graphs. I've got two sides of the equation. So one side of the equation is very easy. I'm going to start with the right-hand side. Y equals 4 is just a horizontal straight line. Y equals 4 through the value 4 on the y-axis. Now the other one is a modulus graph. It's just x minus 3 inside that. So this is just one of the v-type graphs. So using the point of v method, the point of the v is going to be when the thing inside the modulus, x minus 3, equals 0. Okay, so that's a value of x equals plus 3 and y will equal 0. So the point of the v is going to be at the point 3, 0. And the y-intercept when x equals 0, the modulus of x minus 3, y is the modulus of 0 minus 3, the modulus of minus 3 is plus 3. So there's going to be a y-intercept of 3. So I know it's a v-shaped graph, here's the point of the v, so it's going to be a v that looks like this. So the graph shows me that there are going to be two solutions, two places where the two graphs agree. So to set up the equations I need to solve, I need to think about what the equation of each side of this v-shaped graph is. So we know there's one side, so I'm doing the graph of y equals the modulus of x minus 3. I'm not looking at the 4 at the moment, just the modulus of x minus 3. So if the modulus does nothing, one of the two graphs is going to be y equals x minus 3. This side slopes down and y equals x minus 3 has got a gradient of 1. So y equals x minus 3 must be the upward sloping part of the graph, which means the equation on this side is y equals minus. So the modulus is having an effect of minusing everything, so it's minus x plus 3. That minus 3 is inside the modulus. The modulus either leaves everything alone or it swaps the sign completely. So I can see the two equations that I need to solve are for this negative solution, it looks like it's going to be, I need to solve the equation minus x plus 3. Agrees with the graph y equals 4, so that's got to equal 4. Or the other equation is going to be the x minus 3 equals 4. So I'm going to go ahead and solve these. But before I do, I mentioned shortcuts. We could have set these two equations up because there's just one modulus in this equation. Okay, either the modulus is going to make a difference or it isn't. So either it doesn't make a difference, so I get the bottom equation, or it causes a sign swap and I get the top equation. So that's quite a powerful idea, okay? And it can often allow you to just write down the two equations you want without actually having to sketch the graph. So solving the first one, if minus x plus 3 equals 4, then minus x equals, take away 3, equals 1, so x is minus 1. Minus x is plus 1 I should have had first. So first rearrangement, subtract the 3 from both sides, I get minus x is 1. So x is minus 1 from the top equation. The bottom one, even easier, add the 3 to both sides. So this one implies that x equals 7. So the two solutions are x equals 1 or, minus 1 or 7 are my answers. Okay, so I've seen how I can do it using the graphs. Let's do B, where I just go straight to the equations. So the first equation is very easy. Either the modulus causes a sign swap or it doesn't. If it doesn't, then 3 minus 2x is going to equal x minus 1. So that's my first equation to solve. Or the second equation is going to be the modulus does cause a sign swap. So minus 3 plus 2x is going to equal x minus 1. The other side can't change because it's not got a modulus on it. So from the first one, if I add 2x and add 1 to both sides, adding the 1 to both sides gives me 4, and adding the 2x to both sides gives me 4 equals 3x. So that's going to give me x equals 4/3. And on the other side, if I take away x from both sides, 2x minus x is x. I'm going to have to add this minus 3 to get 2 on the other side, so x equals 2. So the two solutions are x equals 4/3 or 2. So sometimes it's as simple as that. You just set up two equations. Okay, so that's equation number 1, that's equation number 2. In the first equation, the modulus had no effect. In the second equation, the modulus had the only effect it can have, which is a sign swapping effect. Okay, that brings us on to part C. Now if we try that same idea on part C, okay, Well, I've now got two modulus signs, so either they, well, the first one could have an effect or not have an effect. The first one doesn't have an effect, I get x minus 1. But then maybe the second one doesn't have an effect either, so I get x minus 1 equals 5x plus 7, okay? Or I get, if the first one still doesn't have an effect but the second one does, I'm going to get minus 5x minus 7. And then, keeping going, the first modulus might have an effect, so it might be minus x plus 1, equaling, if the second one doesn't have an effect, 5x plus 7. Okay, and finally, both moduluses might have an effect. So this looks more complicated. It looks like I'm going to get 4 different equations. Okay. Now, in fact, in this particular case, it's not as bad as it looks because some of these equations are equivalent. So the first one actually is the same as the bottom one. To see that, oh, sorry, that should be a plus 1, shouldn't it? The modulus had an effect, it swapped all the signs. So if the first equation I can actually turn into the last one by multiplying both sides by minus 1. So this top line is algebraically equivalent to the bottom line. So actually I don't need to worry about this equation. And this second line, if I multiply that one by minus 1, I get the third line. So the third line is just saying the same thing as the second line. So this looked like it was going to give me 4 equations, but actually in disguise it's just 2 equations. So solving the first one, I just need to, I'm going to take away x from both sides and I'm going to take away the 7. So I'm going to get minus 8 equals 4x. So that gives me x equals minus 2. And this line here, that should be a minus 5x, shouldn't it? This line here, if I add the 5x to both sides, I'm going to get 6x equals, add the 1 to both sides, minus 7 plus 1 is minus 6. So that gives me x equals minus 1. So my two answers are x equals minus 1 and minus 2. So that one was not too bad. Okay, but sometimes we do have to look a little bit deeper. So this next one, part D, now, as before, I can get 4 different equations. I can have x minus 9. So modulus has an effect, no effect. This modulus also has no effect, so 7x plus 1 looks possible. This modulus still has no effect, but the second one causes a sign swap, minus 7x plus 1. And then the first modulus having an effect, so swapping the sign, but the second one not. And then finally, both moduluses having an effect. So I'm going to get equals minus 7x plus 1. Now, unfortunately now, I'm going to get 4 different answers for x. Sorry, that should have an x on it there. I'm going to get 4 different answers for x. None of those equations are algebraically similar, but not all of those solutions are going to be valid. So we come back full circle. We are going to have to draw the graphs again. So I'm going to do this. This time I'm going to do it not with the point of view method. I'm going to use transformations because these are very easy transformations of graphs. This one here, I've got a minus 9 inside the modulus. So that's going to be a translation by 9 units to the right. It's inside, so it moves it to the right because it was a minus 9 becomes plus 9. So that's going to be a 9 and the y-intercept will be 9. And the equations here are, this is going to be y equals x minus 9 because that's got a positive slope, and y equals minus x plus 9 has a negative slope. And the second equation, 7 times the modulus of x, if I forget about the minus 1, that's times 7 outside, so that's going to cause a vertical stretch factor 7. So that's going to make the graph a very steep V, which is then, with the plus 1, going to be translated up 1 unit. So I'm going to have a very steep V here, and I'm going to have a y-intercept of 1, okay, because it's a steep V moved up by 1. Sorry, my line here isn't very straight here. So this graph, well, the two sides of this one are y equals modulus has no effect will give me 7x plus 1, which has a positive slope. So this is 7x plus 1. And on the other side, this graph here is y equals, the modulus does have an effect, so that will be minus 7x plus 1 on this side. So I can see my 2 points of intersection, okay, here and here, are both on the side of the graph y equals minus x plus 9, okay? So in fact, neither of the top 2 equations applies, because I can see this bit of the graph, y equals x minus 9, actually doesn't intersect the y equals 7x plus 1, okay? These 2 equations, if I solved them, would lead to solutions that don't exist. They'd lead to solutions formed by taking that graph and pretending it, and these graphs all extended further than they really do. There are solutions down here that don't apply because they'd lead to negative y coordinates, which the moduluses stop happening. So this is an example where just doing the sign swaps in your equations isn't quite enough. You've got to use a graph to work out which of the solutions applies. So doing that, I can now solve the equations I've got. So for this one here, I'm going to subtract 1 from both sides. I'm going to add x to both sides. So this one is going to lead to 8 equals 8x, which gives me x equals 1. And finally, this one here, I'm going to add 7x to both sides. So I'm going to get 6x equals, I'm going to subtract the 9 from both sides. So 6x is minus 8. So that gives me x equals minus 8 over 6, which is minus 4/3. So my x values are x equals 1 or minus 4/3. And those are my two solutions. Hooray. Okay. All right. Okay. Hang on in there. There's just 2 more to go. All right. Now the next one. Okay, let's try our luck. Not drawing the graph this time. We've drawn graphs like that before, but let's try not drawing the graph to begin with and think about the 2 kind of equations I could get. So I could get the modulus having no effect, x squared minus 9 equals 7, or the modulus does have an effect, so minus x squared plus 9 equals 7. Okay, so I can solve both of these. If the first one leads to the solution x squared equals 16, so x equals the square root of 16, you say? What must you remember whenever we take a square root? There are 2 possibilities. You always put your plus or minus on. In core 3, if you don't put your plus or minuses in, or the A2 year, the second year of your A level, if you don't put your plus or minuses in, then you will lose marks big time. Okay, second equation. Okay, now it's a minus x squared, so I'm actually going to take 7 away from both sides to get 2. I'm going to add the x squared to both sides, so 2 equals x squared leads to x equals, don't forget your plus or minus, the square root of 2. So this is looking like there are 4 answers. So is that right? Do I believe there are 4 answers? Nothing for it but to check the graph. So what does the graph of x squared minus 9 look like? Well, without the modulus signs, y equals x squared minus 9 would be a parabola, an ordinary x squared graph, but shifted down. Minus 9 is a translation down by 9 units, so it will have its intercept at minus 9. Okay, but that's not the graph I want. I want to put modulus signs on that. So the positive y coordinates are going to be allowed to stay the same, but this bit of the graph is going to be flipped the other way. So if I draw both graphs, I have to draw them on the same axes because I've got to compare x squared minus 9 with 7. So I now know that the x squared minus 9 graph, okay, is a parabola that stops there and there but has an upward pointing bulge in the middle. This is going to be 9 and these are going to be cusps. Okay, if I think about the x-intercepts of this graph, I could actually get the x values quite easily. And on a sketch graph, if they told you to sketch the graph, I'd want to see the x-intercepts. But I'm just getting a picture of what's going on. I'm checking whether I think all my 4 solutions are valid. So this is y equals the left-hand side. Y equals the modulus of x squared minus 9. So I've plotted this. I've got to plot the graph of y equals 7. Now y equals 7 is a horizontal straight line graph that critically it goes through 7 on the y-axis. So it's a straight line that does that, and I can see, lo and behold, I can see 1, 2, 3, 4 intersections. So the graph is a great reality check. If you've got a graphical calculator and can bring that up, then it makes it even easier. But you do see people losing some of these 4 solutions. They forget their plus or minuses. Okay, so the graph is a good reality check. Okay, so although it just confirmed our thinking here, it was not a bad idea at all. And sometimes the question will ask you to draw the graph anyway, so why would you not then use it to help with the equation? So summarize my solutions, not y, I want the solutions for x. So x equals plus or minus root 16. Of course, root 16 is 4. So it's 4, or it's minus 4, or it's root 2, or it's minus root 2. 4 solutions, there they are.